This Zoom session is being brought to you by the Fractal Crystal Ball. Right, for today, we finish off Chapter P, Sections 8 and 9. 8 will be about solving linear and rational equations. Section 9 is about word problems. This means that since we are finishing the chapter as of now, then the first homework, or P homework, we do in a week, assuming, by the way, if the class is still running. This is beyond my, this is above my pay grade to govern. It depends on if there's enough students to justify its the course's continued, this section's continued existence. Again, beyond my control. I just hope that enough people will be enrolled by Friday. But we proceed. And by the way, I won't have to tell you, or you want if Monday you try and sign on and the website does not exist, that would be a sign. And if it does, that means we'll continue, and then that's that. Okay, we proceed. All right, solving equations. Well, that's really what algebra is generally about. So it's a solution of an equation is the value of the variables that makes the equation true. So for example, 2x minus 1 equals 13. It's true if x equals 7. If you set x equal to 7, then left side is twice 7 minus 1 is 14 minus 1 is 13 is the right side. So that's a substitution that checks the solution. So that's how to check them. To find them requires various equation rules. For example, transposition. Equation rules. If you have two equal quantities, then you can add the same number to both sides and it stays the same. Subtract the same from both sides, it stays the same. A times B equals B times C is B times C. A over C is B over C. Minus A is minus B, and 1 over A is 1 over B. Equal operations on both sides of an equation yields an equation. Or an equivalent way of putting it is something called transposition. If you have the equation x plus A equals B, then you isolate x by subtracting A from both sides. X plus A minus A equals B minus A. Plus A minus A cancels, and you get x equals B minus A. So if you have x plus A equals B, then you subtract A from both sides and get x equals B minus A. X minus A equals B, add A to both sides, and you get x equals B plus A. X times A over B, after dividing both sides by A, gets you x equals B divided by A. That's if A is not 0. Division by 0 is troublesome. Let's see, x over A equals B, multiply both sides by A and get x equals B times A. If negative x equals B, well, it's the same thing as negative 1 times x equals B, so it's a special case of adding, of multiplying, that is. But taking the opposite of both sides, the opposite of minus x, which will equal minus B. If 1 over x equals B, then you take the reciprocal of both sides, you get x equals 1 over B. So this is called transposition because this A changes its position. It goes from one side of the equation to the other. And stays the same A, but the operations reverse. Plus becomes minus, minus becomes plus, times becomes divide, divide becomes times. Opposite and reciprocal are their own opposites, their own inverses. So a minus becomes a minus on the other side, a reciprocal becomes a reciprocal on the other side. I like to think that Lewis Carroll, who wrote Alice in Wonderland, and who is also known as his non-pen name was Lewis Dodson. He was a math lecturer at a college, and I like to think that he is riffing on this because Alice, she stayed the same Alice after he went through the looking glass, i.e. equals, but all the operations, all the relations around her reversed. So Plums becomes minus, and Alice, in her case, the straight path becomes like a corkscrew. All very strange. Let's proceed. The idea is to solve an equation, use transposition or the equation rules to isolate a variable. So for example, if 2x equals 34, you divide both sides by 2, get x equals 34 over 2, which is x equals 17. If x plus 2 equals 34, we subtract 2 from both sides. X equals 34 minus 2, or x equals 32. If x over 2 equals 34, you multiply both sides by 2. You get x equals 32 times 4, which means x equals 68. If x minus 2 equals 34, then you add 2 to both sides and get x equals 34 plus 2, or x equals 36. Here we have something where x is buried between several behind several operations. 2x plus 3, that over 2, that minus 5 equals 6. So the way to do it is to invert operations starting from the outside inwards. The last, here's an x, you double it, you add 3 divided by 4, and you subtract 5. The last thing done was subtracting 5, so you add 5 to both sides. Get 2x plus 3 over 4 equals 6 plus 5, which is 11. Now here, 2x plus 3 over 4, the last thing done was dividing by 4. So you invert that, you multiply both sides by 4. Get 2x plus 3 equals 11 times 4, which is 44. Here, 2x plus 3, the last thing done was adding 3. So you do the opposite, you subtract 3 from both sides. Get 2x equals 44 minus 3, which is 41. Here, x is times 2, so you invert that by dividing both sides by 2. X equals 41 over 2, or x equals 20.5 is the solution to the equation. Minus 1 over x equals 5/4. Okay. Here, I think of this, here I think the way, an efficient way to do it is to invert both sides. So minus 1 over x becomes x over minus 1, 5/4 becomes 4/5. Here we're dividing by -1, so multiply by -1, and you get x equals -4/5 is the solution to the equation. Rational equations will have variables and so on in the denominator, and that's annoying. And the easiest way to get rid of the annoyance is to multiply both sides by a common denominator, and thus turn it into a polynomial equation. So, for example, 1 over a equals 1/3 minus 2 over 3a. There's a common denominator of 3a. A, 3, and 3a both go into 3a. So you multiply throughout by 3a. You get 3a over a equals 3 over 3 minus twice 3 over 3a. Now, because it's 3a was a common denominator, it'll cancel out every one of these denominators. Here the a's cancel, 3a over a leaves the 3, equals 3 over 3 cancels, the 3's cancels, leaves an a, minus. 3 over 3a cancels itself, leaves a -2. So we're almost done. 3 equals a minus 2. Add 2 to both sides to get a equals 3 plus 2, or a equals 5 is the answer. If 18 over y plus 1 plus 2 over 5 equals 4. This is denominator is 5 and y plus 1. Lowest common denominator is 5 times y plus 1. Multiply throughout by that. And so 18 times this over this, 18 times 5y plus 1 over y plus 1, plus twice 5y plus 1 over 5 equals 4 times 5 times y plus 1. I hear the first term, y plus 1 cancels, leaving 18 times 5, which is 90, plus. Here the 5's cancel, leaves 2y plus 2. Here, nothing cancels. You just 4 times 5 times y plus 1, which is 20y plus 20. Both of these there's a distribution step, which I skipped here. All right, so what to do? Well, I suppose the simplest thing to do is to do some transposing. Move the 2y to the right by subtracting 2y, and move the 20 to the left by subtracting 20. And you get on the left 90 plus 2 minus 20. And on the right, 20 minus 2y, which, okay, let's see, 90 plus 2 minus 20 is 92 minus 20, 72 equals, and this becomes 18y. And by some dividing, you get y equals 4. I skipped some steps here and here and here. You have p minus 1 over 2 plus 1 equals 3 over p. It has denominators 2 and p. The lowest common denominator is twice p. So multiply each of these terms by twice p. So this term becomes p minus 1 times 2p over 2. This becomes 1 times 2p. This becomes 3 times 2p over p. Okay, here the 2's cancel, and after some distribution, you get p squared minus p. Plus, this becomes 2p. Here, p's cancel, 3 times 2 makes us 6. So p squared minus b plus 2p equals 6. After combining these, the minus p and the 2p and transposing the 6, get p squared plus p minus 6 equals 0. Now this is a quadratic. You can factor this to p plus 3 times p minus 2. So p plus 3 times p minus 2 equals 0. Therefore, either p plus 3 is 0 or p minus 2 is 0, which means that p is negative 3 or p is 2. These are the solutions. Now, sometimes this multiplying both sides by a lowest common denominator creates a solution that wasn't there originally, or is invalid because if you try to plug it in, you get infinities. So the substitutes are called extraneous, because if you substitute into the original equation, you get a division by 0. So for example, 3 over r plus 12 over r squared minus 4r equals negative 7 over r minus 4. Okay, first step is to factor the r squared minus 4r, get it r times r minus 4. So you have denominators r minus 4, and r times r minus 4 and r minus 4. Okay, we'll multiply throughout by r times r minus 4, but it should be noted from here that r can't be 0 because it would involve a division by 0 here and here. And it can't be 4 because that would involve a division by 0 here and here. So we try and avoid those. Okay, so we'll remember that later. So multiplying by r times r minus 4, you get this 3r minus 4 over r plus 12r minus 4 over r minus 4 minus 7r minus 4r over r minus 4. Okay, here the r's cancel, here the r minus 4's cancel, here the r minus 4's cancel. And after that and various other, we'll get 3 times r minus 4 plus 12 is negative 7r. Distribute the 3r minus 12 plus 12 is 7r. 3r plus 7r equals 12 minus 12. That's after some transpositions. This left side is 10r, the right side is 0. So r equals 0 over 10 or 0. So 0 is the only possible solution. But if you plug it back into the original equation here, then we get division by 0. And literally be saying that infinity plus infinity equals negative 7 over 0. Or negative 7 infinity. Okay, it turns out if you add 2 infinities, it can be literally anything. So that's not bad, but it does involve infinities, which is a pain in the neck. So we call this an extraneous root. So when you have a rational equation, it's best to test any root found, because some of them will be extraneous, or it might be. Here we have x minus 4 over x minus 3 minus x minus 2 over 3 minus x equals x minus 3. Now here I have an x minus 3 and a 3 minus x. They are opposites of each other. So we can get an equivalent equation by replacing 3 minus x by x minus 3, and also changing this minus to a plus. So x minus 4 over x minus 3 plus x minus 2 over x minus 3 equals x minus 3. To avoid division by 0, we assume that we'll have to assume from the beginning that x is not 3. Now, right, if we multiply both sides by x minus 3, these cancel. Get x plus 4 from here, plus x minus 2 from here, equals x minus 3 times x minus 3 here. Simplifying this gets you 2x minus 6. Simplifying this gets you x squared minus 6x plus 9. Transpose the 2x, and this becomes a minus 8x. Transpose the 6, and this becomes a 15. So 0 equals x squared minus 8x plus 15. Now this factors into x minus 3 times x minus 5. Negative 3 plus negative 5 is negative 8. Negative 3 times negative 5 is 15. So that fits. 0 equals x minus 3 times x minus 5. Therefore, one of these factors is 0. Either x minus 3 is 0 or x minus 5 is 0. Therefore, x is 3 or x is 5. Now, if you the idea is you substitute the 3 and 5 into this original equation. And if you do that, and if you substitute 3 in, you get 3 minus 4 over 3 minus 3 equals minus 3 minus 2 over 3 minus 3 equals negative 1 over 0 minus 1 over 0. So it's a difference of infinities, which is actually an indefinite quantity. And right is 3 minus 3, which is 0. These don't really quite match up, so we throw it out and call 3 an extraneous root. We set x equals 5 into the equation. The left side becomes 5 minus 4 over 5 minus 3 minus 5 minus 2 over 3 minus 5, which is a half minus negative 3 halves, which is a half plus 3 halves, which is 4 halves, which is 2. The right side is 5 minus 3, which is 2. These match, so x equals 5 is a valid solution, but x equals 3 is extraneous. Here's some other examples. Negative 7w equals 15 minus 2w. To solve, let's first move the 2w to the left by adding 2w to both sides. Minus 7w plus 2w equals 15. Therefore, minus 5w equals 15. Divide both sides by negative 5. Get w equals 15 over negative 5, which is w equals negative 3. Here the equation is 4 times y minus a half. That minus y equals 6 times 5 minus y. Distribute the 4 and you get 4y minus 4 halves minus y equals, distribute the 6, you get 6 times 5 is 30 minus 6y. All right, now we'll move this minus 4 halves to the other side by adding 2 to both sides. We'll add 6y to both sides and move this, so move this to the left. Get 4y minus y plus 6y equals 30 plus 2. Combine like terms, you get 9y equals 32. Divide by 9 and get y equals 32 over 9. And that's the solution of that. Okay, here you have 2x minus 1 over x plus 2 equals 4/5. Okay, let's get rid of the fractions at least. They'll make it that much simpler. So multiply by x minus 2 and x multiplied by 5. So that moves x minus 2 to the right and 5 to the left. That's called cross multiplying. And you get 5 times 2x minus 1 equals 4 times x plus 2. Okay, distribute the 5 through here, distribute the 4 through here, and you get 10x minus 5 equals 4x plus 8. Move the 4x to the left by subtracting 4x from both sides. Move the 5 to the right by adding 5 to both sides. And you get 10x minus 4x equals 8 plus 5. So 6x equals 13, so x equals 13/6. Here we have 3 over x plus 4 equals 1 over x plus 6x plus 2 over x squared plus 4x. Now this x squared plus 4x is the same as x times x plus 4. So what we'll do is we'll multiply both sides by x plus 4. Now before I go on, because x is in the denominator, x can't be 0, because we do be dividing by 0. Because x plus 4 is in the denominator, x can't be negative 4, because again, then we would be dividing by 0. We multiply both sides by x plus 4. For this term, x plus 4 cancels, and we get a 3x. For this term, x cancels, and we get 1 times x plus 4. And for this, the x squared plus 4x cancels, leaving a 6x plus 12. So 3x equals x plus 4 plus 6x plus 12. Transpose the x and the 6x by subtracting. 3x minus x minus 6x equals 4 plus 12. This simplifies to negative 4x. It equals 16. So x is 16 over negative 4, but oops, that means x is negative 4. But that's the only possible root. But it's also extraneous, because if you substitute in, you wind up dividing by 0. So this has only an extraneous root, or if you don't like infinities showing up, it has no roots at all. Here you have something related to something called Kirchhoff's law about the resistances in parallel circuits. It's also related to something I call reduction, which I offer an extra credit set. 1 over r equals 1 over r1 plus 1 over r2. Solve for capital R. Well, the right side will write as a fraction. 1 times r2 plus 1 times r1 over r1 times r2. So that's 1 over r equals r2 plus r1 over r1 times r2. Then you flip it upside down, both sides upside down, this one and this one. On the left, you get R. On the right, you get R1, R2 over R2 plus R1. This is a solution to this. Okay, let's see. There we go. All right, let's stop this momentarily.